Okay, Unit 4, Section 1, Functions. Every single thing, maybe save for step functions, should be a review of what you've done in Algebra 2. Relation, any set of ordered pairs or an equation with two variables. A function is a relation in which each x value corresponds to only one y value. So when you did this in Algebra 2 and even Algebra 1, we looked at the condition that no x values can repeat themselves. Okay, so a relation can be y equals x, or a relation can be x squared plus y squared equals 7. Okay, there's two variables. One of these represents a function, the other one doesn't. Y is equal to x is a line with a slope of 1. X squared plus y squared equals 7 is a circle with a radius of the square root of 7. Redraw that for you. Function, this is just a relation. So determine if the set of ordered pairs is a function. When I just compare my x values, no x's repeat, so that would be a function. 3, when I compare my x values, this would not be a function. And in number 3, I look at my x values, nothing repeats, so that relation would be a function. Okay, looking at the graph of a relation to determine if it's a function, we use the vertical line test. So if I take a vertical line and draw it through the graph, it cannot intersect the graph in more than one spot, no matter where I draw the line. So on the first graph, any vertical line I draw through the function will only intersect it in one spot. When I look at number 2, if I draw a vertical line, that one line intersects the graph in more than one spot. So this would be yes, a function. This one would be no, not a function. Okay, domain and range. Domain are all the possible values for x, while range is all the possible values for y. X is our independent variable, y is our dependent, and then this is our function notation. And our function notation, we know that our y value is equal to f of x. Okay, our parent functions. For each of these, give the name, identify the domain, and sketch a graph. All right, so I am going to name them and do the domain and range, and then I want you to sketch a graph. And whether you have to look it up and see what the graph would look like given the name, then we'll check that next class. All right, so y equals k times x. This is a linear function. Domain and range of any line are all real numbers, never changes. Now notice the value of k. If k is positive, my graph is going to look one way. If k is negative, my graph will look another way. Y is equal to kx squared. This is a quadratic function. Students have a tendency to answer parabola, but the parabola is the name of the graph. The name of the function is quadratic. Domain is always real numbers. Your range is going to change whether your parabola opens up or down. So if k is positive, your range is going to be greater than or equal to whatever the y value of the vertex is. If k is negative, your range is going to be y is less than or equal to whatever the y value of the vertex is. Okay, y is equal to k over x. This is your inverse function. The domain and range. If I look at this, my x values are in the denominator. So my restriction would be that x can't equal 0. If I look at my numerator is a number. That number can never equal 0. So my range would be that y will not equal 0. Number 4 looks a lot like number 3, but notice that our denominator is squared. So this is your inverse square function. The domain is that, again, x can't equal 0. But now your range is going to be different depending on the value of k also. If k is positive, your range will be all positive y values. If k is negative, your range will be all negative y values. And your graph better reflect this when you go to find what the graphs look like. Okay, number 5, that's our absolute value function. Domain is all real numbers. You can substitute any number you want and attempt to find the absolute value of it. Again, your range depends on the value of k. If k is positive, your range will be y is greater than or equal to 0. If k is negative, your range will be all y values less than or equal to 0. Okay, number 6. It's our cubic function. Like the linear function, the domain and range are all real numbers. We really like all reals. Makes it very easy for you. A is a circle, and the circle has a center at the point h comma k, and its radius is the square root of r squared. So my domain, my possible x values are going to, if I think of a circle, they'll be from the center and the radius in either direction. So I'm going to write this in interval notation. My domain will be my center minus my radius will be the left bound. And then my center plus my radius will be the right bound to the domain. Oh. And my range, I do the same, but now with my center, the y value of my center, and I'm going to add or subtract the radius to it. So my lower bound will be my center minus my radius. My upper bound will be my center plus the radius. Okay. Number 8 is your square root function. Okay, domain. If we think about our domain, we can't take the square root of negative numbers. So our domain will be all values bigger than or equal to 0. Your range is going to depend on the value of k. If k is positive, your range is going to be all values for y greater than or equal to 0. If k is negative, your range is going to be all values for y less than or equal to 0. Now I understand I'm doing interval notation for some of them. I'm doing function or inequality notation for others. I guess to be consistent, I'll keep it all inequality, and then we can discuss what the interval notation would be. Okay, number 9, ab to the x power. This is your exponential function. Your domain can be all real numbers. Okay, x represents an exponent here, so you can raise any number you want to a power and get an answer. But your range, and it doesn't matter if it's exponential growth or decay, your range is always going to be y values bigger than 0. Okay, and I put this note in here. This doesn't have a k value. For exponential, we use b as our growth factor. Okay, so that determines what the graph will look like. This is new, okay? Notice that x is bounded underneath. This is your floor, your round down, your step function, okay? You may have learned it any one of those ways. Your domain is all real numbers, but your range are going to be all integers. Okay, and again, we want you to look up what the graph is, sketch it on there, and then we can talk about its behavior. Okay, give the domain of each function. Here's my absolute value function. If I'm talking about my possible values for x, my domain, all real numbers. If I were to write that in interval notation, it'd be from negative infinity to infinity. Number 2, I have a rational function. My domain restriction comes from what would make the denominator equal to 0. So my domain is that x cannot equal negative 3. In interval notation, negative infinity to negative 3, and then from negative 3 to infinity. Okay, so we just have to exclude one value from the number line. Okay, my square root function, the restriction on the square root function, what's underneath has to be greater than or equal to 0. Solving that one-step inequality, I get x has to be bigger than or equal to -2. So my domain in interval notation from -2 to infinity. And I include -2 so it has a hard bracket. Number 4, I have a rational expression. So my denominator can never equal 0. Attempting to solve this for x, I would have had to take the square root of a negative number. That's a non-real solution. So your domain for this is actually all real numbers. Okay, domain, range, and zeros. So we said that the domain is all real numbers. If I use my parent function, this is my absolute value graph with a horizontal shift of 5 units to the left. So for my range, I can see my range is from 0 to infinity, all values bigger than or equal to 0. I guess I'll use interval notation. And my zeros are just x is equal to -5. Remember where zeros come from. It's where your function equals 0. But we also said 3 synonyms for that is your roots, your solutions, and your x-intercepts. So if we now have all these graphs of our parent functions, then all I have to do is look at where my graph intersects the x-axis, and that would be my 0. Okay, here's my quadratic. Domain of a quadratic is all real numbers, always. The range depends on the vertex. So the vertex, the x-coordinate of the vertex, opposite of b over 2a. So my x-coordinate is 4. I need the y value, so that gives me 16 minus 32 plus 12. -16 plus 12. So my vertex is at the point 4, -4. So my range, since a is positive here, I know my parabola opens up. So my range are all my y values greater than or equal to the y coordinate of the vertex. So in interval notation, it would be -4 to infinity. Okay, what are our zeros? Our zeros are where our function equals 0 and I solve for x. This quadratic is factorable. So x minus 6 times x minus 2. -6 times -2 is +12. -6 plus -2 is -8. So my zeros are 6 and 2. Okay, so now looking at the graphs, I want you to determine the domain, range, and zeros for each of these functions that are graphed. Okay, and I know they're functions because they both pass the vertical line test. So complete those for homework.